Hey everybody, Vade here, and today I'm going to be solving all of the AOPS Are You Ready for Calculus problems. The purpose of this problem set is to sort of see if you are, ready to start learning AP Calculus BC in that sort of AOPS style, because they do have their own calculus course, which is approved by the College Board, but does go into far more detail of Calculus 1 and 2. So I'm going to be solving all problems here in this problem set, just so that, if you're confused by some of the solutions that they give down here, I can go through each problem and actually do it with you guys. So of course, please attempt this before watching this video, because, uh, you know, you should of course see, like, what do you already know, before watching this video. Anyway, let's get started. Assuming you've done that. The first is expand x plus 2y whole cubed. So there are many ways of doing this. Three ways that come to mind here is, of course, you can FOIL this out to x plus 2y times x plus 2y times x plus 2y. You can use the Pascal's triangle method, 1, 3, 3, 1, and then do the process, or you can just use the formula a cubed plus 3a squared b plus 3ab squared plus b cubed. So all of this is fine. I'm just going to use the third way. So I'm going to let a equal to x and b equal to 2y. So then we'll have x cubed plus 3 times x squared times 2y plus 3 times x times 2y squared plus 2y cubed. Now it does not say to simplify, so I'm just going to keep it as is, but of course, as you'll see in the answers, it will be simplified. But hopefully your algebra is good enough so that you can actually simplify this if you want to. But this is sort of the gist of it. Okay, the second problem is find the sum and product of roots, real and complex, of x cubed plus 3x squared plus 7x minus 11 equals 0. So there are two real ways of doing this. The first way is not the way I'd recommend. Okay, this is just if you have no clue about like the special Vieta's formulas. Okay, so I'm gonna do that way first, because that's the way I think maybe a decent amount of you guys would do if you do not know Vieta's formulas, which not a lot of people do actually, unless you're more in the competitive math scene. But in sort of, if you were taking an Algebra 2 class at your local school, they probably don't really talk about Vieta's formulas. If they do, then hats off to them. Like they're doing a good job then. But usually they don't talk about Vieta's formula. So let's do this here. Now, to solve this cubic equation, again, we don't have a calculator. Really, two methods you could use. You could probably use a rational roots test or Descartes' rule of signs. It was just clearly evident to me that you could just plug in a 1, and then this would equal 0, if you see what I mean here. If we just let we plug in 1 here, 1 cubed plus 3 times 1 squared plus 7 times 1 minus 11 equals 0. This is just 1 plus 3 plus 7 minus 11 equals 0. This will sum up to 11. 7 plus 3 is 10, plus 1 is 11, 11 minus 11, and that equals 0, right? 0 equals 0. So that just, like, I just plugged in 1, and I was like, oh, yeah, it gave me 0. So that was clearly evident to me. If you do not know, like, the rational roots test, Descartes' rule of signs, hopefully it's just evident to you. If you plugged in 1, oh, it just equals 0 sort of thing. Like, it was clearly obvious to me that 1 was one of the roots. So, knowing that 1 was one of the roots here, I'm going to use synthetic division so that I can get this into a quadratic equation. So I have a 1 here, get the coefficients of the cubic equation. So this will be 1, 3, 7, negative 11. I bring the 1 down here. 1 times 1 is 1, plus 3, 4. 4 times 1 is 4, add to the 7, 11. 11 times 1 is 11, add, and we get 0. This is always good. This means that you did your synthetic division correctly, because remainder of 0 means that it is, in fact, a root. So now we can rewrite this as x squared plus 4x plus 11. And now I'm just going to use the quadratic formula here. This is obviously not factorable, so I'm going to say that here. I'm just going to x is equal to negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 11 all over 2. Now, really, the thing that you want to understand here is, yeah, we can simplify the b squared minus 4ac part, but for finding the sum of roots, it doesn't really matter. So I'm just going to find the sum of roots, like, right now. The sum of roots, right? So we have 1 as a root, and then we have, and the reason why I'm saying we don't need to simplify the b squared minus 4ac for this particular step, or for finding the sum of roots, we will for the product of roots, but not like fully, you don't have to simplify it fully, is because these will cancel because it's a positive and a negative root. So what I mean by that is we'll get 1 plus negative 4 plus the square root. I'm just going to let x equal to this, or not x, u equal to this, and you'll see what I'm talking about, plus u over 2 plus negative 4 minus the square root of u over 2. I'm going to then let 1 equal to 2 over 2, 2 over 2 plus negative 4 plus square root of u over 2 plus negative 4 minus the square root of u over 2. I'm going to put a new page here. But then you'll see here common denominator plus, or I'm going to just say 4, or 2 minus 4 plus square root of u minus 4 minus the square root of u. These will cancel, and we'll get, and then this is all over 2, by the way. This will be then this would be negative 6 over 2, and that would be negative 3. So we would say sum of roots is negative 3. And now for our product of roots here, we just do the multiplication of this. And again, I'm just going to forget I set this equal to u here. I'm going to actually simplify this. I was just trying to illustrate here that for the sum of roots, the b squared minus 4ac part here will cancel. So that's what I meant by, like, oh, just set it equal to u, to sort of show here that that square root will cancel because of the plus and minus root. So now I'm just going to simplify this. Well, let me rewrite this here. X equals to negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 11 all over 2 times 1. And so then this will equal to negative 4 plus or minus the square root of 16 minus 44 all over 2. This would then equal to negative 4 plus or minus the square root of, right, negative 28. Did I do the math correctly? Yeah, negative 28 all over 2. Of course, complex solution, imaginary solution, so this will be negative 4 plus or minus, I'm going to just say I square root of 28 over 2. You can, again, like, actually make the square root into, or simplify this radical here into negative 4 plus, and then this would be 2I root 7, right, because this is 4 times 7. So this will be 2I root 7 over 2. Then we'll get negative 2 plus or minus I root 7. So now we have our 3 roots here. So we have x equals to negative 2 plus I root 7, negative 2 minus I root 7, and 1. So we just do multiplication of these. It's really just this times this, because this times 1 is the same as this times this. So really product of roots, and I'm going to write it anyway, just so it's clear to you guys. Negative 2 plus I root 7 times negative 2 minus I root 7 times 1. Really just multiplication of these two guys here. So we can use the a squared minus b squared. So this will just be 4. I'm just going to show you guys the entire thing. Negative 2 squared minus I root 7 squared. This will be 4 minus then I squared times 7. I squared is negative 1, so this will just be 4 plus 7, which will equal to 11. So therefore, we can just say like sum of roots was, I'm pretty sure negative 3, right? Negative 3, and product of roots is 11. Okay, so this is the long way. This is the really, really inefficient way of doing it. Now, really, the best way of doing it, and it takes like 5 seconds, is using something called Vietta's formulas. So, really, what you need to know about this is like for a quadratic, a second degree, right? Second degree, the sum of roots is, for the second degree, I'm just going to say the sum of roots is negative b over a, and the product of roots, and sorry my handwriting is really bad, is just c over a. For third degree, it's a little different. It's still negative b over a, and then for, I'm gonna actually write this here, sum of roots is still negative b over a, and then product of roots, in this case, product of roots, product of, why can't I write a p? Product of roots is negative d over a, and if you're confused, right, like remember, this is ax squared plus bx plus c equals 0, and this is ax cubed plus cx squared, plus bx squared plus cx plus d equals 0. So in other words, like the c here is the constant for the quadratic, and the d here is the constant for the cubic. So applying Vietta's formula to the third degree, because we're given x cubed plus 3x squared plus 7x minus 11, which is third degree, our sum of roots, we can say therefore sum of roots would just be negative, and then our b here is negative 3 over a, which is 1. And I gotta add another page here. And I can just say product of roots here. Product of roots here is then negative of negative 11 over 1, which, and then this would just equal to negative 3, and this would then just equal to 11. And that's what we got up here, negative 3 and 11. So again, this, what I just did here, synthetic division, all this stuff, yada, 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 is not required at all. Vietta's formulas is something I definitely recommend that you know. And again, the way to derive this, you can derive the second degree one using the quadratic formula. Just multiply the negative b plus the square root of b squared minus 4ac over 2a with the negative b minus the square root of b squared minus 4ac over 2a, and then of course do the same thing by adding for the sum of roots. And then for the third degree, that's a little more complicated. You got to use the cubic formula and do it that way. It's weird, but hopefully these shouldn't be hard to sort of remember here. But for the second degree, that's a little more important to know, I would say. And that's also much easier to derive because we all know the quadratic formula. Not a lot of you guys know the cubic formula by heart. I certainly don't. I'm pretty sure there's other ways to prove the third degree though, but let's not get into that right now. Anyway, let's move on to the third problem here. Solve for x. So we have 3 over x minus 2 plus 2 over x plus 2 equals to 5 over x squared minus 4. Hopefully we can recognize here that if we apply the difference of two squares to this guy here, it'll become an x plus 2 and then an x minus 2, and then our least common denominator here will be the x plus 2 times x minus 2. And what I mean by that is, and I'm going to actually work this out here, so we'll have 3 over x minus 2 plus 2 over x plus 2 equals to 5 over x plus 2 times x minus 2. And another thing to note here, for our domain, we should be a little, how do I say this? We should pay attention to our domain. Like, our x cannot equal 2 or negative 2. I'm going to write this here. X cannot equal to 2 and x cannot equal to negative 2. Why? Well, if we plug in 2 or negative 2 in the denominator, the denominator will become 0, and we cannot divide by 0. Dividing by 0 is undefined. So if we solve for x and we get 2 or negative 2, then that's an extraneous solution. We cannot use that. Anyway, so our LCD here, our least common denominator, would just be x plus 2 times x minus 2. So what I'm going to do here is I'm going to multiply, I can use the other pen, this by x plus 2 times x plus 2, then times x minus 2 times x minus 2. So then hopefully we see here we'll get 3 times x plus 2 times x minus 2, and then this will be all over x minus 2 times x plus 2 equals to 5 over x plus 2 times x minus 2. If we multiply both sides by x minus 2 times x plus 2, these will cancel. And again, that's why this canceling out, we have, because of that canceling out, it's really important that we pay attention to our domain restriction. So then we'll get 3x plus 6 plus 2x minus 4, skipping a little bit ahead here, right? Just distributing these two terms here. So 3x plus 6 plus 2x minus 4, that then equals to this 5 here. Then we'll just combine like terms. We get 5x plus 2 equals 5. We get 5x equals to 3 and x equals to 3 over 5. So yeah, that should be the answer to this question here. Hopefully it makes sense that it's just sort of like getting the LCD and then solving for x, and of course 3 over 5. I'm just going to use the blue marker here. 3 over 5 does not equal to 2, and 3 over 5 does not equal negative 2, so we are safe. Always want to check for that domain restriction. We always want to acknowledge it. We always want to check just in case, because that's often what students miss, right? They miss this domain restriction here. It's more like hard to, or people usually miss it more with quadratics, or not quadratics, radicals like square roots and fourth roots, like all the radicals with the even indexes. That's what the students usually miss the most. All right, let's move on to the next one. If Richard, I hope that's alluding to Richard, the founder of AOPS. That would be nice, right? If Richard can paint their living room in 4 hours and Vanessa can paint the same living room in 5 hours, then how long will it take for them to paint the living room together? Okay, so this is sort of like our work problem here. So like a work problem. Have you guys ever done a work problem? Hopefully you have, because work problems are awesome. Okay, so Richard can paint his room in 4 hours. Okay, this will just be, and I'm going to write 4 here because we're on problem 4. If Richard can paint his room in 4 hours, this will be a 1 over 4. And then Vanessa would be a 1 over 5. Okay, this is just how work problems work. for every one room, it's 4 hours, right? Think of it like this. For every one room, it's 4 hours. For every one room, it's 5 hours. And how long will it take for them to work together? So this will be for every one room, X hours. Okay, so we can't just do 4 plus 9. Not how it works. Okay, and you'll see why. So we'll have to solve here by just adding up times 5 times 5 times 4 times 4. We get 5 plus 4 over 20 equals 1 over x. 9 over 20 equals 1 over x. X times 9 over 20 equals 1. X equals 20 over 9. So 20 over 9 hours is what will take the both of them combined. Okay, sort of a trick question here. Students will tend to add the 4 and the 9. Like if it takes them 4 hours for one room and 5 hours for one room, it does not necessarily mean 9 hours, right? Because they're working together, right? It's an algebraic relationship if you sort of think about it. It's not like, oh, takes 4 hours, takes 5 hours for them to work together. It's 9 hours. It's just not how it works. Like, obviously, it's going to be more efficient if they both work together. It's not like it'll take more time, if they both work together. So that's what confuses students a lot. So it's just an algebraic relationship. One for one room is for one room 4 hours. For one room 5 hours. How long will it take for them for one room for X hours? That's what we're trying to find together. So this is the together side. This is like individual, individual. Okay, so work problems won't show up. I mean, I don't think this type of format necessarily in AP Calculus. I'm not 100% sure, but it's, again, really good to know all this stuff. I'm not saying never. So now determine the sum of the infinite geometric series with first term 3 and common ratio 2/5. This will 100% show up in AP Calculus, okay? This is like, you will do some like series and stuff and proving like convergence. You can use this formula here that you've hopefully learned in an algebra class, which if you, again, 5 here, you'd be using the formula a sub 1 over 1 minus r, where a sub 1 corresponds to the first term in geometric series, and then r is of course that like constant ratio, right? Like it's always being multiplied by some constant ratio. And here it's actually very straightforward because they're just telling us this stuff and we have to plug it into the formula. But one thing to note here, now AOPS isn't really trying to trick you here, like they just want you to know, like to check if you know the formula. But I mean, if they were trying to trick you, r technically has to be greater than -1 and less than 1 in order for this to work. If not, then this geometric series, infinite geometric series, would be divergent. That's probably a term you're not really familiar with because that's a calculus sort of term. In other words, it's not possible to actually find that definite value that this sum is. Like when you find the sum of something, like it's sometimes impossible. In this case, for like if you find an infinite sum, it's not always it's not possible for a lot of summations to like how do I say this? Like if you have a sum, again, this is sigma notation. Hopefully you're familiar with this. Like, let's say I equals 0 is our index variable to infinity. If we have this to like x squared, right? This is not possible. Like this would be 0 squared plus 1 squared plus 2 squared plus 3 squared plus dot dot dot. This will just go towards infinity, and that's not an acceptable answer for a sum. Because infinity is like a concept. You can't really, like, it's not like a descriptive limit sort of thing. If you, yeah, you should know limits if you're like, usually pre-calculus classes cover limits. So hopefully you get what I mean here, like descriptive limits. It's not like really that acceptable for a summation. You can't use Gauss's formula here, like the n times n plus 1 over 2, because the n is infinity. Infinity times infinity plus 1 over 2. Do not do that. That's just not possible. Like you'll still get like infinity in a way. So yeah, this is like impossible. So there has to be certain conditions in order to find the like um, infinite summation. And in this case, like r, they gave us r equals 2/5, right? Like here, r or a sub 1 is 3 and r is 2/5, right? The 2/5 is greater than -1 and less than 1. And maybe that should make sense also. It's not really a memorization thing because if you have some geometric series here, like again, the standard form of a geometric sequence, like this is how the series would actually look here. We can say I equals 1 to infinity, and this would just be a sub 1 times r to the I minus 1. Hopefully you understand here that this is like an exponential function, right? There's going to be like an asymptote, and it'll always like converge to a value. Like, in other words, let me think of it like let me make I equal 0 here to infinity, and do a sub 1 3 times 2/5 to the n. This is what I'm talking about. Like this exponential function here has an asymptote, okay? And that's what you're trying to like. This has a horizontal asymptote, and that horizontal asymptote is what this would essentially like converge to, because it's getting like the values as we go, right? As it gets greater and greater and greater and greater, that denominator, right? That denominator is smaller or is larger than the numerator. So then this, like if we do like if when we get to, and by the way, this should be n. Um, yeah, I should probably use I. I'm going to use I here. Use I here. Um, hopefully you get what I mean here. I, um, if we like let I, once we get to like iteration 5 or whatever it is, like what if we get to iteration like I equals to 5,000, we get 3 times 2 over 5 to the 5,000. This will be 3 times 2 to the 5,000 over 5 to the 5,000 using properties of exponents. 5 to the 5,000 will obviously be much larger than 2 to the 5,000, right? 5 to the 5,000 will be much larger than 2 to the 5,000. So this will be some pretty small value. Be some small value. So then 3 times that small value, like it'll get smaller and smaller and smaller, and then it'll, because of that horizontal asymptote, it'll just convert. It'll converge again. Like guys don't really know the vocab yet. Maybe it'll approach, like it'll become sort of that like one constant sort of value here. So then it'll be some definite sum. Okay, I don't know why I'm talking so much. Sorry about that. I'm just trying to get you guys to understand this formula a little bit more. And this is sort of what to expect in a calculus class in a way. Like this is like how you sort of want to think about it in the calculus context as well. Of course, there's a lot more to series, and that was, I think, too much from my side. But anyway, plugging this into the formula here, we'll get S equals to a sub 1, which is 3 over 1 minus 2/5. And it didn't tell us to simplify, so this is the answer that we can would be acceptable. And this is College Board standards right here. If you're doing an FRQ, you're allowed to leave your answer like this from my experience. But if it's an MCQ, you should definitely know how to simplify this. And in fact, we can do this right now. 3, and this would just be 5 over 5 minus 2 over 5 would be 3 over 5. So 3 times 5 over 3. These will cancel, and we just get 5. The sum will equal to 5. Okay, so that would be our answer to that question. Okay, actually, wait, I don't know. Not 5. 5 over 5 over 6, I think, right? This would become, let me do the entire thing here. 3 over a sub 1 is 3. 1, 5 over 5 minus 2 over 5. This would be 3 over 5 equals to 3 over 1 times 5 over 3. Should, yeah, equal to 5, I think. Yeah, let me check the answers here. Yeah, 5 is correct. Sorry. I was just doubting myself for some reason. I thought it was 5 over 6. Um, yeah, anyway, let's do number 6 here. Number 6 is compute log base 9 of 27. Okay, many ways to do this here. I'm going to let this equal to y. So then, using our properties of logs here, 9 to the y must equal to 27. So really, we have to think about 9 to the what equals 27. So I'm going to rewrite this as 3 squared, because 9 equals 3 squared, to the y, and then of course 27 equals to 3 cubed. So really the best strategy for these types of things, whenever possible, is to get that common base. In this case, our common base is 3. So this will then become 3 to the 2 times y, because this and this will multiply according to our properties of exponents. And then that equals to 3 cubed. The bases will cancel. I don't know, wrong thing. Bases will cancel. We get 2y equals 3, so then y equals 3 over 2. So we can say, therefore, log base 9 of 27 equals 3 over 2. You want to check that. 9 to the 3 over 2 equals 27. You just do the square root of 9 cubed equals 27. Using properties again, exponents, 3 squared cubed equals 27. This will become 3 to the 6 equals 27. This is squared, so using properties of radicals, this will be 3 to the 6 over 2 equals 27. 3 cubed equals 27. That's a true statement. So yeah, that's pretty much it. Number 7, factor completely. X to the 6 and a minus 1 over the real numbers. So in order to think about this here, it's just applying the difference of two squares formula, and then the difference of, I think the difference of two cubes. I'm just looking at I'm just trying to eyeball this. So let's try it here. A squared minus b squared. This will just be x cubed minus 1 times x cubed plus 1. Okay, I see here. So then x cubed, right? This would be plus x cubed minus. Yeah, this would be correct. And then we can further simplify this. This is actually a really nice problem. Good job, AOPS. By the way, I've not tried these problems yet, so I'm trying it with you guys. That's why I'm thinking through this with you guys. X cubed minus 1, x cubed plus 1. This is our difference of two cubes and sum of two cubes formula. So then, again, this is all just knowing your formulas. So this would be a minus b, right, times x squared plus x plus 1, right? A minus b times x squared plus x a squared plus ab plus b squared. And then this times a plus b times a squared minus ab, so then x plus 1. And it says factored over the real numbers. Now, one thing to note with these formulas here, and again, like I'm going to explicitly write the formulas here just so that you know here, like this we used an a squared, we used a squared minus b squared, and then here we used a cubed minus b cubed and a cubed plus b cubed. a squared minus b squared. We used this already in a previous problem. That's just a plus b times a minus b. A cubed minus b cubed is just a minus b times a squared plus ab plus b squared, uh, and then a cubed plus b cubed equals to a plus b times a squared minus ab plus b squared. The minus ab is one thing that people mess up the most, right? It's minus ab, and then this one's like plus ab. This one's easier to remember than this one, but yeah. And by the way, there's no really sum of two squares formula, like a squared plus b squared. Yeah, sure, it equals c squared, but you know what I mean. Um, but yeah, and then the one thing to note with these formulas here is that the a squared plus ab plus b squared and the a squared minus ab plus b squared, these are never factorable over the reals. Okay, these will always not never be factorable. These will these, if you think of this as like its own like quadratic equation, and this is its own quadratic equation, you find the roots. These will be complex, or they'll be imaginary solutions. So this is therefore like this is the most you can factor it over the reals. So it's just using a squared minus b squared and a cubed minus b cubed and a cubed plus b cubed. So really nice way of testing the understanding there, or if you know your formulas. Anyway, moving past algebra here, let's go to geometry. Um, find the area of the shaded region lying inside a circle of radius phi. Let's see if I can fit this here. So we need to find the area of the shaded region. I'm going to try to draw this out myself. This is what, number 8? Number 8. So let's see if I can draw a circle. Is there a shape feature here? I think I can. Okay, there we go. Can I draw a line here? Okay. Little triangle. Good enough, good enough. So this is not a circle, is it? Just pretend that this is the center of our circle, okay? Just pretend that this is the center of our circle. Just ignore that it doesn't look like it is. But yeah, so this should be 120 degrees. This is radius 5. And we're trying to find the area of this like shaded region. So what we need to think about here is that this is one of 3 sectors of the circle. We can divide this into 2 other sectors by drawing this line here. So then we'll have one sector here, one sector here, and one sector here. We have 3 sectors. And since it gives us 120 degrees here, we can find the area of this entire sector, then subtracted by the area of this entire triangle here. So really what I mean by that is area of a sector. Hopefully you know this. It's just area of sector is just theta over 360 degrees, or 2 pi if you're dealing with radians, times pi r squared. And hopefully that's kind of common sense, like pi r squared is the area of the circle, but then you're just dividing that into the sector, the angle of that sector. So in this case, it'll be 120 degrees over 360 degrees times pi times 5 squared. 120 over 360 is 1/3, and then times 25 pi. So we have 25 pi over 3. So this is that entire sector. 25 pi over 3 corresponds to the area of this entire sector right here. But we want to find just this shaded region here. But we're given a triangle, so we can find the area of this triangle. So assuming you don't memorize formulas, I'm just a guy that doesn't memorize formulas, but maybe you should memorize this type, like this is isosceles triangle, if you didn't know, right? The legs are congruent because, radius is 5. I'm just going to convert it into 2 right triangles. So I'm going to make this 60 degrees, and this is 60 degrees. And wait, this is a right triangle, so this must be 30 degrees. This must be 30 degrees. This is our special right triangle here. So I know my special right triangles. You should know your special right triangles. I don't necessarily know all of the area triangle formulas. Like I could have technically used Yeah, no, why would I do that? I could have used like Heron's formula or something like that, but who would do that for like when you have right triangles? It's like the stupidest thing ever. Um, so this is again, this is like the 2x. The hypotenuse is the 2x. Adjacent to the 30 degrees is the x root 3. So if this is 2x, I'm going to say x is 5 over 2, so then this must be 5 over 2 root 3, and this must also be 5 over 2 root 3. So then the area of this, and then this will be this will be x root 3, 2x, so 5 over 2. So really, then AB over 2 is the area of a right triangle, so just 2 times AB over 2. I know the 2's will cancel, but I just want to draw sort of write out the whole process. So 2 times, because it's 2 right triangles, times 5 over 2 times 5 over 2 square root of 3 all over 2. These will cancel. And then we'll get, I hate running out of pages. Then we'll get 5 or 25 root 3 over 4. So this is the area, the 25 root 3 over 4 is the area of this entire triangle. So we want to do the area of this entire sector, which is 25 pi over 3. I'm going to write 3 here, it doesn't look like a 3. And then that subtracted by the area of this triangle, which is this guy right here, will give us the area of this shaded region. So I'm just going to write 25 area would equal to 25 pi over 3 minus 25 root 3 over 4. Okay, so 25 pi 25 pi over 3 minus 25 root 3 over 4 is the answer. Okay, so just some basic, maybe geometry, area of a sector, special right triangles, unless you know that there is another formula for this. It's something with a root 3. It's like derived from the special right triangle. I could derive that formula, but I just wanted to put it into my 2 special right triangles because that's how I remember it. But it's probably better if you remember that formula that doesn't make you have to split it up into 2 special right triangles. Anyway, find the equation of the line passing through the points. Yeah, just checking. Yeah, the line passing through the points, and this is problem number 9 here. Line passing through the points 2, 3, and 5, negative 1. So it's just a basic algebra 1 slope question. I'm just going to let this equal to x1, y1, x2, y2. So m, which is our slope, which will just be y2 minus y1 over x2 minus x1. So this will then equal to negative 4 over 3. So then I'm going to use point slope form, which is, remember, y minus y1 equals to m times x minus x1. You're welcome to put it into y equals mx plus b slope intercept form, but I think it's more efficient to just put it in point slope form. So then we'll just get y minus 3 equals to negative 4 over 3 times x minus 2. And then that should be the correct answer. So let's move on to the next one. Find the area of the region bordered by the lines, and we'll write 10 here, bordered by the lines 4x plus 7y equals 14, x equals 1, and y equals negative 2. This one, maybe you have to think about it, maybe you don't have to think about it. I'm going to think about this here like by drawing a little picture, not too accurate of a picture, but you get what I mean. So this would be negative 1, this would be negative 2, this would be the line y equals negative 2. I can use some color here. This is y equals negative 2, and then x equals 1. That'll look something like this. That is not a line. Okay. And then, of course, we have the 4x plus 7y equals 14. Um, I don't really need to actually sketch the exact like slope and all that kind of stuff. I'm just going to like let me make assure myself, right, like 7y equals negative 4x plus 14. I see here that the slope is going to be negative because if I divide by 7 on both sides, this will be negative 4 over 7 is the slope. So slope is negative. So the line, of course, will intersect 2 because divide by 7, this should be, b should equal to 2, right? So it should intersect 1, 2, should intersect here, and the slope is negative. So it should look something like, I'm going to use blue here again, should look something like this. Okay, so we need to find the area of this guy right here, right? Because this is bordered by these 3 lines. Or no, not this guy right here. This guy right here, right? Because this is bordered by the 3 lines as such. This line, x equals 1. This line, y equals negative 2. And then this line, approximately 4x plus 7y equals 14. So in order to, how I was thinking about, or how I was going to think about this, I've seen this type of problem before. So my thought process for this type of problem is like, well, I want to know the distance from 2, right? Like this is, or negative 2, right? And again, we're trying to find, this is a right triangle. If you're unaware here, we have an x equals 1 and a y equals negative 2. These are both like lines that once they intersected should form a 90-degree angle. So it's a right triangle. So we really just need to know this side and this side in order to find the area, right? We can say this is A, this is B. Area is, of course, AB over 2, like we did in the last problem. So, of course, the distance from 2 to the point of intersection between the line and y equals negative 2, or no, the distance between the distance between negative 2, which is, this is again negative 2, the distance from here to the point where the line intersects the x equals 1 should be the length of this thing. So what I mean by that is we go from negative 2 to then, of course, when x intersects, when x equals 1, right, when it intersects with the line x equals 1, x actually has to equal 1, so we just solve for y. So we do 4 times 1 plus 7y equals 14, so I get 4 plus 7y equals 14, 7y equals to 10, y equals 10 over 7. So really it's just the distance from 2 to 10 over 7. Okay, so this is, well, like the distance between negative 2 and 10 over 7, which should be right here. This would be, like if we want to think about the point here, this would be 1 comma 10 over 7. The distance from the y equals negative 2, right, the negative 2 to the 10 over 7. So from negative 2 to 10 over 7, so we go plus 2, that's 0, plus 10 over 7. So it's just 2 plus 10 over 7 is the distance. So this, therefore, this length here, this length would be 2 plus 10 over 7. Now, same sort of logic for this length right here. For this length, we need to think about, well, we go from x equals to 1 to when the line intersects the y equals negative 2. So we go from the x equals 1 to the x value when the line intersects the 4x plus 7y equals 14 line intersects the y equals 2 line. So in order to do that, well, we just plug in 1 in for x. So we get 4, or no, 1 in 4, or 2 in, sorry, what am I saying? Negative 2 in for y, because when it intersects that y equals negative 2, we need to know that, like, we need to know the x value, the corresponding x value to that point of intersection. So we do 4x plus 7 times negative 2 equals 14. Then we'll get 4x equals to, or 4x minus 14 equals to 14. 4x equals 28. X equals 7. So the distance from 1 to 7. The distance from 1 to 7 is, of course, 6. Right? The distance from 1 to 7 is, of course, 6. So this will be 6. So really our area then, right, remember A equals AB over 2. This will just be 2 plus 10 over 7 times 6 over 2. So, yeah, we can simplify it. Why not? This will just be 14 over 7 plus 10 over 7 times 6 over 2. Gotta add a new page. Yeah, I can just go here. This will be 24 over 7 times 6 over 2. This will be a 1. This will be a 3 times 3. And then, I don't know if I did this right. Did I do this right? No, I think I did this right. Right, 24 times 3 would be 72. 72 over 7. Yeah, right. Let me check here. I'm prone to making mistakes here. Yeah, 72 over 7. So yeah, the area here would equal to 72 over 7. The area of that region bordered by these three lines. So hopefully it makes sense. Like, you're trying to find like point of intersection, corresponding y and x values. And I think the picture really helps. So you can sort of see this like logically. It has to be the distance from here to here, obviously. Do that. This is the y equals to negative 2, but what is that? Or no, what am I trying to say here? This is that x equals 1 line here. I want to know the corresponding y value here. This is that y equals negative 2 line. I want to know the corresponding x value here. We had to sort of do some math by using the equation of the line, plugging in 1, plugging in negative 2, solving for the y here, solving for the x here by plugging in these. And that's how we actually, and then we had to think about like the distance from negative 2 to 10 over 7, right? Distance from 1 to 7, because it's a triangle, right? From here to here, from here to here. This times this over 2 will give us this area of 72 over 7. Okay, so yeah, I just drew the picture. But hopefully if you see a problem like this in the future, like, think about just like, maybe to be efficient, you don't need to draw the picture, but hopefully you can sort of visualize in your head, like, what's going on. This is what's actually going on. So, yeah, let's move on to the next problem here. It is, I think, the last of our geometry. It is sketch the graph of the equation. Right, yeah, it's the last for geometry. X squared plus y squared plus 2x plus 4y equals 11. So hopefully you can tell, like, immediately that this is the equation of a circle. And the standard form of the equation of a circle is x minus h, that's not centered at the origin, is x minus h the whole squared plus y minus k the whole squared equals to r squared, where r is the radius, right? R is the radius. Hopefully you got that. And then h comma k is the center. And of course, if h and k is 0, centered at the origin, it'll just be x squared plus y squared equals r squared. So anyway, you're probably like, how do we get this into this? Well, we got to use our completing the square from algebra 2. We got to complete the square twice. So I'm going to first affiliate the x terms with the x terms and the y terms with the y terms. I'm just going to bring them closer together. So this will be x squared plus 2x plus y squared plus 4y. This will equal to 11. So now we need to figure out what we can add here and subtract here and subtract here to get this into a perfect square. So what I mean by that is we always use the b over 2a squared method. So we just, because remember standard form of quadratic is ax squared plus bx plus c. We do b over 2a squared, and then we add it, and then it should be a perfect square. So in this case, our b is 2, a is 1, so we square it, so we get x squared plus 2x plus, and then b over 2 times a, or yeah, b over 2 times a squared. And of course we have to subtract it because if we're adding this, we have to add it to the other side. We can think of it like that. If we're adding something to the equation, we have to add it to the other side as well. Squared. And then same thing here. Y squared plus 4y plus then b over 2 times a squared. You got to add it to this side of the equation as well. Now, I'm going to simplify this here to x squared plus 2x plus then 2 over 2 squared. That's just, remember, parentheses first. 1 squared is 1. Then plus y squared plus 4y plus then 4 over 2 is 2. 2 squared is 4. This then equals to 1 plus then this should be 1 plus 4. 1 plus 1. Alright, 1 plus 1 plus 4. So now these two should be perfect squares. So this will just be, hopefully from your knowledge of factoring, this should be x plus 1 the whole squared plus then y plus 2 the whole squared. You can check by foiling it out. We're using the a squared plus 2ab plus b squared formula. So then this will then equal to this will then equal to, did I do this correctly? I don't know if I did this correctly. Wait. Is this the correct equation? X squared plus 2x b over 2a squared 1 11. It should be 11. Sorry, I was so confused. This should be 11 11 11. Yeah. This should then equal to 16. Okay. So now, hopefully, we understand here that knowing that r is the radius, this is r squared, h comma k is the center. We can identify our variables here, so we know that h will equal to negative 1, k will equal to negative 2. Remember, it's the opposites, right? This is the plus, it'll be a minus, plus it'll be a minus, because of our rules of transformation, or just knowing, right, negative h, right? If this would be negative of a negative in order for this to be positive, so therefore h has to be negative 1. Same thing is true here. And then, of course, r squared, if r squared equals 16, r must equal to 4, and radius must be positive. That's just how math works, right? Like, think about the unit circle, or think about, like, when you're in trig, and of course we're gonna have trig problems a little bit in this problem set. If you draw a triangle, regardless of the quadrant, right? Like, sometimes your x here, this will be like a negative x, a positive y, but whatever this is, like, we can say like your z here, again, not like the z axis. Just think of it like x, y, and then z. Like, z is the hypotenuse, just a variable. This will always be positive regardless of the quadrant you go into. If it's like a z here, positive, z here, positive, z here, positive. Actually, yeah, z here, positive. So that's how you want to think about it. So that's like, and again, like, actually, I could probably like state here, like, if you think about the unit circle, like how we do it there, like, we have a circle here. The radius will also be the hypotenuse of the triangle, sort of thing. Right, just like, yeah, just like our last problem, like the problem we did. like the problem we did up here. Like the radius was the hypotenuse. The radius of 5 was also the hypotenuse of this triangle. That hypotenuse has to be positive, sort of thing. Okay, regardless if we're on the Cartesian plane or not. That's just how the math works. So, with that in mind, we'll have okay, sorry, I think my mic cut out. We'll have a circle. We'll have a circle centered at -1, comma -2 with radius 4. So let's sketch it real quick. We can sort of put here -1, -2. So x is -1, y is -1, -2. So this is our center here. Our radius will be 4 units. So it'll go all the way to 1, to 1, 2, 3, 4. Yeah. So this is how it'll be. Something like this. No. Well, I mean, how am I not? Why am I not able to sketch graphs? Yeah. Something like this. This is what your circle should look like. I don't think that's 100% correct. 1 second. Why am I so... Something is up. Wait, so this is -1, -2, radius 4. From the center, 1, 2, 3, 4 units. From the center, 1, and then this will be -4, -5. 1, 2, 3, -6, 4. Okay. This is what our circle well, I can use the circle tool here. This is what it should look like with its crap. That center is really bad. Let me... Yeah, works. This is how it should sort of look like. I don't have graph paper, and that's why I think I was having a little bit of trouble. Sorry about that. But this is how it should sort of look like. I think it's more about, like, if you were asked a question like sketch it, like, I don't think the criteria would be too strict. I think it's more about the process, like finding the center and finding the radius using completing the square. I think that's a little more. I think that's a lot more important than the sketching. Yeah, I don't know why I had trouble with that. Sorry about that. Let's move on to trigonometry now. Okay, so number 12 is evaluate the following quantities. So we have a sine of pi 6, b cosine of pi halves, and c tangent of 5 pi by 4. So this is really purely unit circle stuff. You can use special right triangles if you're really stuck. You know what the savage move would be? The savage move, right? If you were in calculus, is just hit them up with the pi 6 minus pi 6 cubed over 3 factorial plus pi 6 to the 5th over 5 factorial minus dot dot dot. This is what I'd put, because this is the Maclaurin series for sine, so it's like using You can actually make a polynomial that approximates sine using the series. It's cool stuff. And the dot 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 means that it will exactly equal to that. So yeah, no. Well, let's use the unit circle. So to sine of pi over 6, right? Let's just like pi over 6. You should hopefully know this. This is like the y coordinate of the unit circle. This should really make sense. Please do not go into calculus without knowing the unit circle, or at least, you know, being clueless about it. So this will just be 1 half. Cosine of pi halves will be 0. And then tangent of 5 pi by 4. I got to think about this. 7 pi by 6, 11 pi by 6, 5 pi by 4, 5 pi by... And sometimes it's good to like graph it out, like quickly sketch it out. Like, oh, it should be right here. This is the 5 pi by 4. Think about what it corresponds to. This is this tangent here, like the ASTC. Tangent is actually positive here, so it should be 1, right? Because tangent is also positive here, and the tangent of pi fourths, which is right here, would be 1. This is 5 pi by 4. You go pi radian, increase by pi radian, 5 pi by 4. It's also going to be 1. So, yeah. Sometimes if you know, like, you gotta, like, do a bunch of trig in order to, like, to doing, like, even like 3 years of trigonometry, the unit circle probably won't come instantly to you. Like if you get like cosine of 11 pi by 6, maybe that you could get it in like a second. Or sometimes you maybe need to like draw out like just a little like picture here. Now, again, like the person who gets the trig value in like a second will have, of course, an advantage of like maybe 10 or 20 additional seconds of time on their test because they know the unit circle a little better. But drawing pictures like this, it's not really the worst thing. Like, of course, if you're like gonna redraw the entire unit circle, like, oh, this is pi 6, this will be square root of 3 over 2, comma 1 half. Then we go to pi fourths. Then this is square root of 2 over 2, comma square root of 2 over 2, etc. If you keep doing that, that's of course like terrible. Like you should have a general, like, again, like they say, know the first quadrant. First quadrant can easily be derived using your 30 60 90 or 90 45 45, or 30 60 90 pi by 6, pi by 3, pi by 2, or your pi by 4, pi by 4, pi by 2 triangles. That's how you can derive the first quadrant. Then everything else, all the other 3 quadrants, are pretty straightforward, without you know, just only knowing the first quadrant. Now, in my understanding, not memorizing YouTube series, I am going to go over the entirety of the unit circle, like using special right triangles. So stay tuned for that. That'll be coming soon. So yeah, this is just simply you got to know your stuff sort of thing, like unit circle, like fundamental for calculus, because in the AP exam they could ask you problems on like MCQs or FRQs that don't allow a calculator, like as part of a problem. They won't just say like what is sine of pi by 6. That's an algebra thing. You may have to do some derivative, like find the slope or find the equation of the line tangent to this point, some trig function, or some application. No calculator, but you need to know your unit circle. Like that's where you need to know the unit circle. Like you need to know these angles, like sine, cosine, tangent of the angles and what they equal to. I'm not too sure about if you need to like the angle sum formula. If you need to like, I don't think the College Board has really ever asked like, oh, what is the sine of some degree of some angle that's not on the unit circle, on the AP. What I mean by that is if you're trying to find the equation of the line tangent to like, let me think here. 75 degrees. Like you need to find tangent of 75 degrees in order to get the slope. Either you leave it that way, or you, like in an MCQ case, if it gives you the numerical value, you'd have to, the only other way of getting it is like if you know what I'm talking about here, like tangent of 75 degrees, for example, that's the same as tangent of 45 degrees plus 30 degrees, and then you can use the tangent angle sum formula, so it'd be like tangent 45 plus tangent 30 over 1 minus tan 45 tan 30. So you need to know this, but I don't think they'll do that. So again, this stuff is like solid. Like you gotta know this stuff. And again, don't be afraid to draw like a picture like that. Always can help, but don't make it too detailed, like the entire unit circle. Okay, number 13. Number 13 is find all theta between theta is greater than or equal to 0 and less than or equal to 2 pi, such that sine theta plus cosine theta the whole squared equals to 3 over 2. The one thing that trips people up with this type of problem is that you square root both sides. Now, if you square root both sides, what you'll notice is that this is plus or minus square root of 3 over 2. Now, this is not a unit circle ratio. So, you gotta try something else, is what, like, unless you, this won't be a unit circle thing. But it is possible to do this without, like, you could use a calculator and get the answer by square rooting it, but you're not allowed to use a calculator on this problem set. So, we have to try something else. So really, the best way of doing this is to actually FOIL it using the a squared plus 2ab plus b squared, just doing sine theta plus cosine theta times sine theta plus cosine theta. I'm just going to use a squared plus 2ab plus b squared, or you can, of course, do the 1, 2, 1 with the Pascal's triangle. Whatever suits you. So I'm just going to do sine squared theta plus 2 sine theta cosine theta plus cosine squared of theta equals to 3 over 2. Now, hopefully you realize here, this is like a good test of both solving trig equations and your identities. Sine squared theta plus cosine squared theta, Pythagorean identity, that's just 1. Watch my understanding, not memorizing series if you don't know how I got that. And then plus 2 sine theta cosine theta, that's the double angle identity, so that's just the same as sine 2 theta. Again, watch my understanding, not memorizing series if you or in the future when I do post about the double angle identity. First, I have to do the sum and difference before that, because with the sum and difference, you can actually get the double angle identity. Stay tuned for that, and this will then equal to 3 over 2. Okay, so now, sine of 2 theta equals to 3 over 2 minus 1. Oh wait, 3 over 2 minus 2 over 2 is the same as 1. That's just 1 over 2. 1/2 is a ratio in the unit circle, right? So now, what kind of trips people up is we have the 2 theta here. So the first thing you'd want to do is, again, you want to pretend that it's first of all like sine of theta equals 1/2. So when sine of theta equals 1/2, what does theta equal to? Well, it's only one answer. Theta, or sine of theta, or no, it's not only one answer, it's two answers. Sorry. For sine of theta equals 1/2, it should be it should be at pi theta equals pi over 6, comma 5 pi over 6. And don't be afraid, like I said for the last problem, like draw a picture. Like remember, this is the same as like, and again, I'm dealing with radian here because it says theta is between 0 and 2 pi. These are both radian because if it doesn't have a degree sign, it's automatically implied radian. Also 2 pi radian. 2 pi, we usually, like, we don't say 2 pi degrees. That's not like a unit circle angle. Anyway, so if we have pi by 6 and 5 pi by 6, you know, if you're confused on how I got that, like think about like, oh wait, first quadrant of the unit circle, this is like this is pi over 6 here. This is square root of 3 over 2, comma 1/2. And how, oh wait, this is ASTC, right? If you don't know, this is like the all students know calculus sort of mnemonic here. So like this is all are positive, sine and cosecant are positive in this quadrant, tangent, cotangent are positive in this quadrant, and then secant and cosine are positive in this quadrant. So 1/2 is positive, so of course here, which would be 5 pi by 6, okay, would also be, this would be then of course negative square root of 3 over 2 because we're on the negative side of the x-axis, then 1/2. So that's the thing, again, like draw a simple picture if you're like, if you just need a moment to think about like, oh well, what does theta have to equal to for sine of theta to equal 1/2. Okay, anyway, right, like this sign is the y on the unit circle, so 1/2, 1/2. Anyway, so we pretended that sine of theta equaled 1/2, but now since it's 2 theta, well, what do? Well, we put just 2 theta equals 2 pi over 6, comma 5 pi over 6. Okay, so actually, you know what I'm going to do here, because it may make it a little easier, is we're going to first get the general solution. So what I mean is, like, we use like the plus n pi plus the 2n pi sort of thing. So in this case, like, ignoring the interval just for a split second, it'll be theta equals to pi over 6 plus 2 pi n, comma 5 pi over 6 plus 2 pi n, right? Because if you go from pi over 6 to, you add pi, that won't equal to 5 pi over 6, so it'll just have to do one revolution back to pi over 6, and the same is true for 5 pi over 6. So now, I gotta add a new page again. So now we can just say 2 theta equals to pi over 6 plus 2 pi n, and this is not really correct notation-wise, I'm just going to use a comma here, plus 2 pi n, because then if we divide by 2, again, not really correct notation-wise, these will cancel, and we get, or no, sorry, not correct notation-wise. Let me rewrite this as theta, right, equals to pi over, or no, I can just do it above here. If I multiply this both sides by 2 to get 2 theta, because we have the 2 theta here. So then we'll get 2 theta equals to 2 pi over 6 plus 4 pi n, or no, I was doing it correct before. So we have theta equals this. Like, we can say that because sine of theta equals to 1/2, right? We pretended that, but we can actually say here 2 theta equals to this, because, yeah, how do I sort of explain this? Like, this is the argument of both, right? This is the argument. Theta is the argument here, 2 theta is the argument here. Regardless of the angle, sine of something will equal 1/2, right? In this case, this something is theta. In this case, this something is 2 theta. Let's let this equal to u, right? Like, if we let this equal to u, sine of u equals 1/2. U, like, if sine, let me this actually even better. Like, let's pretend sine of u equals 1/2. U would then equal to pi over 6 plus 2 pi n, comma 5 pi over 6 plus 2 pi n. Substitute u in for 2 theta, then 2 theta must equal to pi over 6 plus 2 pi n, comma 5 pi over 6 plus 2 pi n. Again, the comma is not really correct syntax-wise, but it's still, like, it's more about the understanding. So yeah, pretend, like, ignore this. I shouldn't have used theta twice. I could have just, like, this is better, like, I used u instead. Sine of u equals 1/2. I got u equals to this, and then before substituting 2 theta back in for u, 2 theta equals this, and we have to solve for theta, right? Because it's always saying, like, find the value of all theta. Or if can you see my mouse in this window? I don't think so. Here. Yeah, find all theta. And sorry if I'm not, like, scrolling along this document. Like, probably should be doing that so you guys can actually see the problem. Even though I wrote it down, find all theta, right? Find all theta. We have to actually find this guy right here. So we have to isolate it. So we can do that by dividing by 2 on both sides. So I was correct before. I don't know why I stopped myself. Just needed to remember that we're actually trying to solve for theta, not 2 theta. So then we'll get theta equals to pi by 12 plus pi n, pi by 12 plus pi n, and 5 pi by 12 plus pi n. So remember our interval here. This is theta is greater than 0 and less than 2 pi. The interval itself doesn't change. But now we need to see how many times, and by the way, n, usually teachers don't require this, but the n belongs to, it's a special z symbol here. This is just integers because n has to be an integer. That should make sense, right? Because you can't have part of like if you're going from this point to this point, it has to be like one full, I don't want to say revolution because a revolution is like 360 degrees, but hopefully you get what I mean. Like you can't do 0.5 times pi. Like you got to do it one time. You got to do it two times. Like you go like from this angle to this angle, right? From this angle to that angle, from this angle to this. Like you get what I mean? Like you can't do that partially. Defeats the whole purpose of the general solution. But you don't really need this. Um, but again, anyway, we have to see how many times we can add pi to both this, and this, because we need all theta between 0 and 2 pi. Okay, and this is hard, but it's not easy. Like you saw me mess up a little bit like earlier, but I caught my mistakes, luckily. But like yeah, this is a little difficult for people in general. Keep in mind, I'm doing calculus. I haven't done this type of stuff in a while, but it's really good to know this stuff because it will show up. So this will be pi over 12, and I'm going to let n equal 1. So this will be 12. Well, not why did I put an equal here? Pi over 12 plus 12 pi over 12, and then 5 pi over 12 plus 12 pi over 12, because I'm just letting pi, like pi is the same as 12 pi over 12. I let n equal 1. So I'm just going to say let n equal 1. So then I got 13 pi over 12. 13 pi over 12 is less than 2 pi. It's not equal to 2 pi, but it's even if it was, it would be correct, but obviously it isn't. And then this would be 17 pi over 12. And if we let n equal to 2, and hopefully this is obvious to you, but we can do it again. So we do pi over 12 plus 2 pi, comma 5 pi over 12 plus 2 pi. This would then be pi over 12 plus 24 pi over 12, and then 5 pi over 12 plus 24 pi over 12. We already have a 2 pi here, but we're exceeding 2 pi by adding, of course, the pi over 12, so 5 pi over 12, which is literally our solutions. So obviously, our solution set here would be theta would equal to, of course, our pi over 12, 5 pi over 12, and the additional 13 pi over 12, and 17 pi over 12. And if we let n equal to 2, then it would be greater than the 2 pi value here, and that would be outside of the domain restriction. And remember, if it doesn't give you this interval here, then you, of course, it's actually less work for you in a way. Like in this case, yes, sometimes the general solution may be more work, but if you're always going to do it like using this method, especially when you have like a 2 times an angle in the argument, which can make it a little more complicated. The angle divided by, like, if it was divided by 2, it'd actually be a little easier because of this tight domain restriction. It's usually 0 to 2 pi. That's if they restrict it to something. But if this was not given to us, then literally this would be all you had to write. But since this was given to us, we need to find all theta within that interval. So yeah, this should be the correct answer to that problem, to this problem here. So now 14, sketch the graph of 3 sine of 2x plus 1. So this is 14. So we have y equals to 3 sine of 2x plus 1. So really what you want to think about first is, like, what is this in the form of? This is in the form y equals to a sine of bx plus c. So we know that a is the amplitude, b, like we want to do 2 pi over the absolute value of b here. Usually people do 2 pi over b. Usually in a pre-calculus class, you don't really, like a traditional pre-calculus class, you don't really deal with the b's being less than 0, but you should always just put 2 pi equals the absolute value of b to be safe, but 2 pi over b usually works. 2 pi over absolute value of b will give you your period. And then like the bx plus c equaling 0 is like your transformation. Your transformations. Like, don't even think about trigonometry. Like, if we have, let me just write this side. If we had like x minus 2x minus 5 squared, 2x minus 5 squared, right? This is a quadratic, it's a parabola. Let me say f of x equals to this. This will be moved, again, 2x minus 5 equals 0, 2x equals 5, x equals 5 or 2. This will be moved 5 over 2 units to the right, right? Because these are rules of transformations. They apply to our trig graphs as well. So really, we know that really, I don't even know what I was trying to say here. Let's solve the problem. So our amplitude here, and we need to know this information because when we actually graph it, we need to know the amplitude and the period. The period is like the cycle. Like one full cycle is a period when graphing trigonometric functions. So in this case, a is 3, right? The a is 3. So, all right, a equals 3, period. So that'll be p. I'm just going to write p equals to 2 pi over absolute value, and this is our b here. 2 pi over absolute value of 2 equals to 2 pi over 2, which will then equal to pi. And of course, we want to actually make our bx minus c, 2x plus 1 equals 0, 2x equals negative 1, x equals negative 1 half. We're going to start from here. So keep in mind, whenever you graph a transformed sine graph, you also want to like first visualize like what the regular sine graph looks like. Right, so the regular sine graph looks like, and again, if you're doing this on like a test or something, you probably don't want to like draw the like I mean, just have the general like sketch in your head, right? Like we start at 0, like this is 1, negative 1 is a range, so we start at 0, go from 1, 0, negative 1, 0, like this is one entire period here. 0, 1, 0, negative 1, 0. So in this case, like amplitude is 3, so we'll have something like this, and this is, by the way, sine of x, just to not get confused. So this, in this case, amplitude will be 3, so it'll be the distance from the, we call this the midline, but in this case the midline is the x-axis, since we didn't have any vertical translation. Like if we had a plus c and the c was like 5 or something, like the midline would definitely not be the x-axis. It would be the mid, like if we think about this here, we just do, we would translate these points according, like the negative 3 we translate it up 5. So negative 3 plus 5 is 2, and then the positive 3 plus 5 is 8, so 2 and 8. And then the 2 plus 8 over 2, that would be your midline then. Y equals to that. But in this case, y equals 0. Midline's just the x-axis. So then our starting value, instead of 0, it'll just be negative 1 half. So it'll just be moved here, negative, did I do this correctly? Negative 1 half. 2x plus 1? Yeah, negative 1 half. So we'll be moved 1 half left. So this will be negative 1 half. So it'll be 0, and then it'll be, the next value would just be, again, our period here is pi, so the next thing would just be like something negative 1/2 plus pi, and then at this it'll be like a 1, and then we do pi a again, and it didn't give us an interval for what we have to graph. Like, I'm just going to graph one period. It just said sketch the graph. Technically the graph is infinite because it's periodic, but anyway, this will just be like negative 1/2 plus 2 pi 0 1 0, and then negative 1/2 plus 3 pi negative 1. And I'm saying negative 1, but it's actually negative 3, just because I visualized this graph in my head. And then 0 1 0 negative 1, and then 0. This would just be negative 1/2 plus 4 pi. This is what it should sort of look like. And I just want to check here. Yeah, this is sort of, yeah, it graphed a little more. Did you guys see this? No. Can I zoom in, maybe scroll down? This is how it sort of graphed it here, which is of course more, but it didn't specify how much you need to graph. So now down to our final problem here. New page for the final problem. Simplify cosine of pi halves plus I sine of pi halves to the 9th. Okay, so it's saying simplify this. So, of course, you're probably like, what the heck? I cannot possibly foil this. This will take years to foil. And that is correct. And in this case, you really shouldn't foil. In fact, if this was a test, even if you did foil and you lose time on your test if you were doing this. Even if there was unlimited time theoretically on your test and you had a problem like this and you foiled, you probably wouldn't even get full credit for this. You'd probably be a laughing stock. You probably weren't paying attention to class, because you can actually apply something called de Moivre's theorem. This is one of my favorite theorems of all time, de Moivre's theorem. You can get so much out of this. Oh my god. You can get Euler's identity out of it. It's like the most beautiful equation of mathematics. E to the pi I plus 1 equals 0 comes from de Moivre's. You can derive it from de Moivre's. There are other ways to do it, but it comes from that. So that's kind of cool. But anyway, de Moivre's theorem, if you want to know it or recall it, is just cosine of theta plus I sine of theta to the n power. And there's like two ways. This is not the there's like two parts to this, but this part would just be like this is the part of de Moivre's theorem that we need over this problem. Cosine of theta plus I sine of theta to the nth power will just be cosine of n theta plus I sine of n theta. So, knowing de Moivre's theorem, we could say that n is 9, right? N is 9. So then, in this case, this would then equal to, using de Moivre's theorem, cosine of 9 times pi over 2 plus I sine of 9 times pi over 2. Isn't that much easier than actually foiling out cosine of, let me write this here because it's just funny, cosine of pi over 2 plus I sine of pi over 2 times cosine of pi over 2 plus I sine of pi over 2 dot dot dot. Like, isn't that funny? Now, again, Pascal's triangle, right? Like 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, dot, dot, dot. Like, this is the Pascal's triangle thing that I keep talking about. Could use that, but that would still take so long. Oh my god. Just don't do that. This took like 5 seconds, knowing the coolest theorem of all time. It isn't really the coolest, but it's one of the cool ones out there. I just got this. This is the same as this. Isn't that crazy? cosine of pi over 2 plus I sine of pi over 2 to the 9th power is just cosine of 9 times pi over 2 plus I sine of 9 times pi over 2. Is that crazy? I think so. So then this will just be, wait, this is pi over 12. Sorry, pi over 12. Should get my math right. Should get my writing down, copying right. This will then equal to cosine 9 over 12 is the same as, this should be the same as 3 over 4. 3 and 3 pi over 4 plus I sine of 3 pi over 4. Why was I doubting that? I don't know why. Yeah, times 3 times 3. Okay, so then cosine of 3 pi over 4, unit circle, gotta know it, gotta love it, or special right triangles, either way. You can, again, like unit circle comes from special right triangles, or you can go directly from the special right triangles to get these answers, but that may take a little longer depending on, like, you know. Anyway, so cosine of 3 pi over 4, I'm just going to draw my ASTC here to recall. Again, I told you guys earlier what this stands for, why I write it. All students take calculus. Why I actually write that down. But 3 pi over 4 is in this quadrant right here, quadrant 2. And cosine is negative there, so it'll be negative square root of 2 over 2 plus I, and then sine is positive here, I square root of 2 over 2. And then that should be the correct answer to that problem. So yeah, this is been a long video, 1 hour and 36 minutes of math. This is a lot of stuff, guys. A lot of stuff, lots of stuff here. Yes, hopefully enjoyed here. Sorry if I was like struggling a little bit on some of them. This is my first time attempting these types of or not these types of problems, these specific problems. Someone just told me I should, you know, to really test if I, like, I'm already studying some I'm already studying calculus right now. I've studied a lot of calculus already, at the time of recording. So like, just want to make this video. But yeah. Thank you guys for watching. Sorry it was so long. Sorry I struggle a little bit. It's just because I don't memorize answers. I don't do these problems beforehand. I actually solve them with you guys. Blast from the past. Right here. The trig, the geometry, the algebra. Wow. It's been a while since I've done problems without the word derivative or integral being in them. Yeah.